It is late in the day when a critical zero-day is disclosed. The first question is simple: are we exposed? The answer is usually buried across software inventories, endpoint tools, cloud consoles, identity systems, spreadsheets, and people who may already be offline. Meanwhile, the clock is moving. Attackers can use automation and AI to analyze public details, search for reachable targets, and adapt activity faster. Defenders can use AI too, but asking a chatbot what to patch is not preemptive security. The real change is a connected operating model. Continuously know what software exists, map new threat intelligence to your environment, calculate which combinations create real blast radius, apply mitigations before a patch arrives, and turn technical evidence into actions that security, IT, and leadership can understand. This CipherVibe explainer follows the playbook described in Rapid7's 2026 article, then tests it against public work from Google Project Zero and DARPA's AI Cyber Challenge. We will separate demonstrated capability from marketing claims, mark preview features clearly, and show the human controls that keep AI-generated guidance from becoming a new source of risk. A zero-day vulnerability is a software or hardware weakness that defenders do not yet have a normal remediation cycle for. A zero-day exploit is code or technique that uses that weakness. A zero-day attack is the real-world use of the exploit against a target. Those terms are often blurred, but the difference matters. Discovery does not automatically mean exploitation, and a public disclosure does not prove every vulnerable instance is reachable or compromised. Even when the exact flaw is unknown, defenders can still observe surrounding facts, software versions, exposed services, authentication paths, privileged identities, unusual processes, outbound connections, and attempts to cross trust boundaries. Think of zero-day defense like preparing a city for a storm whose exact path is unknown. You cannot predict the street where the first tree will fall. You can still map hospitals, power lines, evacuation routes, weak bridges, and emergency crews before the forecast becomes urgent. AI helps process the map and the new forecast quickly. It does not replace the map, the crews, or the decision about which road to close. Preemptive security starts by reducing uncertainty before the crisis, not by pretending uncertainty has disappeared. Popular beginner technology explainers are effective when they start with a recognizable problem, reveal one layer at a time, compare choices visually, and return to one memorable analogy. They use short chapters, large labels, animated arrows, and frequent changes in emphasis instead of filling the screen with paragraphs. We will adapt those broad presentation techniques without copying another creator's wording, scene composition, artwork, branding, or thumbnail. Our visual model is a storm operations center. Continuous software visibility is the city map. Threat intelligence is the forecast. Exposure analysis identifies which weak bridge sits on the route to a hospital. Mitigation closes or reinforces that route before repairs arrive. A patch is the permanent repair. Monitoring confirms whether the storm is already causing damage. AI is the coordination layer that can connect those data sources, highlight relationships, summarize options, and shorten handoffs. Human owners still validate the forecast, approve road closures, test repairs, and accept business risk. Every chapter will add one layer to this loop. By the end, the response to a zero-day changes from scan everything and hope to 4 specific questions. Where is it? How reachable is it? What can we safely do now? And how will we verify the result? The first layer is continuous software visibility. Traditional inventories are often periodic snapshots. They miss short-lived cloud workloads, unmanaged devices, bundled libraries, browser versions, container images, and software installed outside the normal process. When a zero-day appears, analysts lose time asking whether the affected component is present. A useful inventory connects software name and version to the asset, operating system, cloud account, network location, owner, business service, external exposure, and last seen time. It should combine multiple sources and show uncertainty instead of hiding it. Rapid7's article describes software visibility, marked in preview, mapping emerging threat criteria against installed software. Its example asks whether Safari versions earlier than 18 exist across the environment. The general principle is vendor neutral. Normalize a threat condition, match it against current telemetry, and return the affected footprint quickly. Do not respond to every disclosure with a massive disruptive scan. Use existing high-quality telemetry first, then target safe validation where coverage is missing. The common mistake is confusing collection with visibility. Millions of records are not useful if software names are inconsistent, assets are duplicated, owners are unknown, or data is weeks old. AI can reconcile and query the data, but governance and telemetry quality determine whether the answer is trustworthy. After finding affected software, the question changes from "are we exposed?" to "how exposed are we?" An outdated browser in an isolated training sandbox is different from the same browser on an executive workstation connected to sensitive systems. A vulnerable service behind strong authentication and segmentation is different from one exposed directly to the internet. A low-privilege workload is different from a system with cached administrative credentials. Rapid7 calls these toxic combinations, multiple conditions that form a meaningful attack path. The useful inputs include internet reachability, exploit activity, privileges, identities, secrets, data sensitivity, network paths, control coverage, asset criticality, and business dependency. AI can help join these graphs and let analysts ask natural language questions, but the answer must expose its evidence. Which assets matched? How fresh is the data? Which identity creates the privilege path? Which control reduces likelihood? A confident sentence without traceable evidence is not a risk decision. Use generic severity to start triage, then use environment context to order action. Do not allow an AI summary to silently lower a critical finding or invent a relationship. The storm analogy makes this simple. A weak bridge matters most when it sits on the only route to the hospital. Context turns a flaw list into a prioritized defense plan. Here is a practical example using synthetic data. A browser vendor discloses a 0-day affecting versions earlier than 18. No reliable patch is available yet. The security team converts the advisory into a clear condition: product family, affected versions, platforms, known exploitation status, and observable behavior. The inventory returns 120 matching devices. Exposure analysis narrows them to 12 devices used for privileged administration, for internet-facing kiosks, and one executive workstation with access to sensitive applications. The remaining systems are isolated training machines. Now the team chooses proportional controls. It may restrict the affected browser from privileged workflows, route critical users to a managed alternative, disable a vulnerable feature when vendor guidance supports it, strengthen web filtering, isolate high-risk systems, increase telemetry, and monitor for relevant behavior. Exact mitigations must come from validated vendor or government guidance. Never invent a registry change or command from an AI answer. IT receives device owners, business services, recommended interim controls, validation steps, and rollback instructions, not just a spreadsheet of IP addresses. When a patch arrives, deployment begins with canaries, health checks, staged rings, and confirmation that vulnerable versions disappear. The speed comes from preparation and correlation. AI accelerates the reasoning and communication. Approved change control makes the response safe. A 0-day often creates a dangerous gap between disclosure and a tested patch. Preemptive security uses existing controls to reduce risk during that gap. Possible approaches include disabling an affected feature, narrowing network access, changing routing, enforcing stronger authentication, removing unnecessary privilege, blocking vulnerable file types, tightening application control, using web or email filtering, isolating critical assets, or increasing detection. The right choice depends on how the vulnerability works and how the business uses the system. Compare 3 approaches. Patch immediately when a trusted fix exists, active exploitation is likely, and rollback is ready. Apply a temporary mitigation when no patch exists or operational testing needs time. Isolate or suspend a service when impact could be severe and safe mitigation is uncertain. AI-generated remediation summaries can translate technical findings into environment-specific options. Rapid7 marks this particular summary capability as available now, while several adjacent features in its article are labeled preview. But generated guidance must cite the underlying advisory and identify assumptions. A hallucinated command, wrong platform, stale package name, or unsafe configuration could create an outage or weaken security. Require human approval, test in a representative environment, use explicit targets, record changes, define rollback, and verify the control actually blocks the relevant path. Temporary controls also need expiration dates so they do not become permanent technical debt. The broader claim that AI can change vulnerability defense has real evidence behind it. Google Project Zero and DeepMind reported that Big Sleep found a previously unknown exploitable memory safety issue in SQLite before it reached an official release. Google described it as the first public example of an AI agent finding this kind of issue in widely used real-world software. The work used an AI-assisted vulnerability research framework and expert review, not an unsupervised model patching the internet. DARPA's AI Cyber Challenge asked cyber reasoning systems to find and patch vulnerabilities in open-source software. DARPA reported that finalist systems significantly advanced automated discovery and quality patching, and the competition used controlled infrastructure, scoring, and responsible disclosure. These examples demonstrate different jobs. Discovery agents analyze code and behavior to find unknown flaws. Exposure systems determine whether a newly described flaw matters in a specific organization. Remediation systems propose or generate changes. Security operations systems correlate telemetry and communicate decisions. Use each approach where its evidence is strongest. Code reasoning agents belong in controlled software security workflows. Exposure AI belongs over governed asset and identity data. Generated patches and mitigations require tests, code review, and rollout controls. Operational summaries should link back to source evidence. The mistake is treating every system with AI in the label as interchangeable or assuming demonstration under controlled conditions proves safe autonomous production use. Zero-day response crosses team boundaries. Security analysts need the advisory, affected assets, attack paths, observed behavior, confidence, and control gaps. IT operators need owners, deployment groups, prerequisites, maintenance windows, validation, rollback, and user impact. Executives need current exposure, critical services at risk, actions underway, decision points, and residual uncertainty. All 3 views should come from the same evidence graph. AI can produce audience-specific summaries, but the underlying counts and definitions must stay consistent. If the board report says 12 critical assets while the change ticket lists 9, the difference should be explained, not hidden. Rapid7's article describes AI dashboard summaries as an in-preview capability for converting dense dashboards into narratives. The general advantage is saving analyst time and improving shared understanding. The risk is polished language that outruns the evidence. Label generated content, show timestamps and coverage, link to supporting assets, distinguish confirmed facts from estimates, and identify the human owner who approved the action. Do not send secrets, personal data, or sensitive vulnerability details to an unapproved model or connector. Good communication is not a decorative report at the end. It is part of the control loop. Leaders set priorities, operations execute safe changes, analysts verify exposure, and everyone sees when uncertainty has actually decreased. The zero-day playbook is changing, but the winning idea is not let AI handle it. Build continuous software and asset visibility. Connect software to owners, identities, exposure, data, controls, and business services. Track data freshness and gaps. When a new threat appears, translate it into testable conditions. Match those conditions to the environment. Rank toxic combinations using reachability, privilege, exploitation evidence, criticality, and compensating controls. Choose the response that fits the moment. Patch when a trusted fix and safe rollout exist. Mitigate when the patch is unavailable or needs testing. Isolate when severe impact is plausible and uncertainty is high. Increase monitoring and hunt for behavior that would show the weakness is already being used. Use AI to reconcile data, accelerate queries, surface relationships, draft remediation options, and create audience-specific summaries. Require source attribution, human validation, least privilege access, privacy controls, tests, change approval, rollback, and outcome verification. Avoid stale inventories, blind faith in severity scores, massive untargeted scans, invented AI commands, untested patches, permanent temporary controls, and executive summaries disconnected from evidence. Remember the Storm Operations Center. AI can read the forecast and connect the map faster. People still decide which bridge to close and confirm that the hospital remains reachable. The goal is simple. When the next zero-day drops, replace frantic discovery with prepared decisions. Copyright 2026 CipherVibe. All rights reserved.